Welcome. My name is Blair, and I'm coming at you from wonderful Vancouver, British Columbia. And today we're going to talk about AI and decision making. And it's just like this picture in front of you. If you have an angry crab coming at you, a compass in one hand, a knife in the other, what are you going to do? Are you going to go for the compass? Are you going to do the knife? Can AI help you at all? This is all in good fun, but today we're going to look at some of my projects where I've implemented large language models in business settings to help support good decision making. So let's get started. This theme that AI won't take your job, but someone using AI will really resonated with me. I think it's really true. I'm not sitting around philosophizing about large language models. Getting up every day and applying large language models within my organizations. And so I think it's so important to sort of share these ideas to really stoke people's creativities. They can see how I'm sort of structuring different problems and then sort of reflect back in their own organizations and see how they can fit their own use cases to solve problems and really support analytical decision making in ways that are really radically innovative. Just to quickly introduce myself a bit more, I'm currently a data scientist for the SureSpan group of companies. I sit at the headquarters in North Vancouver's, where I work on the AI projects for several different of their companies. I have a master's of applied science and civil engineering where I focused on machine learning, and immediately completing that, found myself working on LLMs full time. Previous to that, I worked in lots of design and engineering studios. And this had a really great effect on my ability to problem solve. It really exercised my ability to think in multidisciplinary, creative, and collaborative ways. It allowed me to sit across the table from the user and really understand their problems and be able to communicate creatively the types of changes that we need to undertake to be successful. And I really feel working in design and engineering studios really prepared me well to apply these novel integrative solutions. So much of the success I've seen in the application of large language models comes down to a question of scale. Completely possible to dig a hole with a hand shovel, but I got a lot of stuff to move. I want the front end loader. I want the giant tractor. And it's not appropriate sometimes when you're dealing with a lot of data to be individually copy and pasting things into a ChatGPT window. This is where learning to code is so important, to be able to wrap your ideas into applications and into pipelines is really what leverages some of the analytical prowess of large language models in a business setting. And it really allows and facilitates a lot of the reporting needs of organizations. So I wanted to start with some high level takeaways before we turn to four different case studies. The first being is that the following case studies, they all work with what we say is a pay-as-you-go large language model endpoint on either AWS or Azure. We have found this to be a very cost-effective and performant way to get apps out to users. And it's been really, really great how quickly we can move just using these pay-as-you-go endpoints, and we've been completely happy with the cost point. Another thing that goes along with that is so far what we've deployed has all worked on prompt engineering. We find the performance excellent, and again, it allows us to move really quickly and be adaptable and get the low hanging fruit and get to get these tools to users really fast. We do have some sort of research level projects in fine tuning models, but everything that's deployed right now, it's all using prompt engineering. If I had to categorize use cases that are good applications of LLMs, I would say that I look for repetitive, analytical, skilled jobs. These are often done by junior business analysts or junior engineers, and these are really good cases where you can write these pipelines and do a lot of that analytical front end work before they sort of go into the details. This isn't so much a technical talk, but I did want to mention that all these following case studies all have validation scripts with them, and this is where there's a subset of human evaluated data that we know is correct, and we constantly compare it to the output of the LLM, and this allows us, one, to sort of understand the margin of error we might be seeing, and also be able to understand if there's any drift in the model over time. This is a case study one. Here, the client wanted to automate the quarterly reporting of, of a portfolio of buildings' carbon emissions. The use case was rather straightforward, is that it was taking about 80 hours every quarter for analysts to write this report, and it was believed that these hours would be better spent on other projects. We had a small historical data set to work from, but looking at the historical data set, it was quite straightforward to sort of break out that report into different sections and have a different agent work on each section, sort of bringing them all together at the end. And you can see this sort of framework here is how I kind of thought about all these different agents. Some agents just sort of took other types of reports and digested them, and other ones we actually wrote some Python functions that went into a building analytics database, or like a building performance database for the time period under question, and took back some data. We did some other sort of transforms of the data in Python, and I gave that data to the LLM to summarize. Again, bringing this all back at the end with some text processing and some other agent summaries, and then this could be used by the building owners to make decisions about how to reduce the carbon footprint of their portfolio of buildings. Now we come to case study 2. This was what I call the Attender Docs AI. Basically, to prepare a bid or an estimate of a potential project can be highly technical, can be very tedious, and therefore very expensive. And that expense really impacts an organization's ability to bid on all the work they want to get. So we wanted to sort of shorten this cycle time to get a proposal to like 80%, where then a skilled person could come in and finish those details that really help us win jobs. We had a pretty good historical data set of proposals and completed bids to work from. So the first question we had was like, how do we get this information out of this data set? And so we built just a basic RAG agent. And we sort of thought of this like of sort of a buddy agent that could sit with a junior estimator. It was like a senior estimator that could just had perfect knowledge of all previous projects. And that worked really well. Then it came to sort of automating it in a more complex way. Again, we sort of think of it as more of a bid payload because we're uploading it to another system, but ultimately it's just sections. And we broke it down into different prompts, setting the different LMs, so we could have sort of fine-grained control over each section that could identify weak points. And we sort of all brought this together again with some processing at the very end there, and then we created this bid payload. And all this helps us be more competitive and putting up more quality bids, so we get more quality work in. For case study 3, I was asked to undertake a transport cost analysis, and this was an analysis of our transportation costs of moving equipment and materials from yards to site and sites back to the yard. We do have this big enterprise database, but over time, the cost, the invoice cost, became detached from what was being transported. And so we have all sorts of needs to be able to estimate and make predictions about what's being moved, but there was no easy way to go back in this historical data at all for the normal user to go back and make a prediction and to use the knowledge that's there. So over the course of 2 months, I slowly took all these PDFs of invoices that we knew that the cost on the invoice, and we extrapolated information from these invoices. Basically, first I scraped the PDF I found the best performance was to scrape the PDF's text and then send that to the LLM. I took some different characteristics from that, a detailed description of the load, the origin, and the destination. And once I had that married back to that original data set, where the cost was, I kept on using those descriptions to add more columns. Was it an oversized load? I categorized the load. And then this as I made the data set wider with augmenting it with new types of data, those become features for more traditional machine learning. And basically then I made 2 different types of prediction models. One, a more classic clustering models, just to be very quick off the top of your head prediction, and a bit more sophisticated one based on random forests. And we took different parameters, and then it sort of spits out an estimate for the load that you're trying to move. Again, this is all a way to be able to drive quality decision making within our organization. Now we come to the last project, case study 4. And even though that flowchart at the bottom looks the most simple, surprisingly, this project probably had the biggest impact. For a civil engineering construction company, it's very important to always have this pipeline of potential projects coming in. And part of that is to find high quality proposals in a sea of low quality proposals that have nothing to do with the organization. And it really takes a skilled professional a lot of time to look through these bids and find ones that match our experience and expertise. There's also a time constraint on it because sometimes there's dates to follow up on that happen very quickly after the bid is posted. It was taking someone from about 7 to 14 hours a week to find bids to follow up on. And we felt that this time was better spent on finding or refining the details of one of our bids, because these bids are really one on the details, but we were spending so much time just finding ones to follow up on. And this is why I came up with our AI bid analyzer. This took sort of a collection of bids every day and analyzed them. And we asked the LLM to assign a match score to it. And this match score represented how well this potential proposal matched our skills and experience. And it turned out to be very successful. And it returned this table of match scores. And you just followed the highest match score to the lowest to find which high quality bids to follow up on. We also created a summary of the summaries that sent a list of potential high quality bids to the executives to also follow up on. Um, one of the best things about this project, it was that when we deployed it at the beginning of August, we decided we wanted to keep running this manual process of human-centered effort to find these potential bids. And along with the bid analyzer, we just didn't want to miss anything. And so we were going to follow up in 2 months and to get any feedback. But when we went to set the meeting at the beginning of October, we were very surprisingly told that the estimating team had completely moved over to the AI bid analyzer. And it was so gratifying to so well address a pain point that there was essentially no change management. And again, it really allows us to make better decisions. We were saving so much time and we can make better decisions on which bids to follow up on, that we could be much more confident in working on the details of a bid to always be working towards these high quality projects. I wanted to end by saying that these applications are so new, there's not really a category to put them in. There's not really a name that you can just search online to learn more. There's still lots to do to formalize this intersection of data and AI and how it supports better decision making. And I'd be very interested to hear what others have to add to the conversation. But I'll end by saying thank you very much for watching. Please feel free to leave any questions along with this video, and please share. It would be a very big help to me. Thank you very much.